Welcome to this explainer, where we're going to completely break down algebraic functions and master section 11.1. Look, if equations with an x and a y usually leave you feeling a bit, well, lost, you're definitely in the right place. Today, we're taking those abstract math concepts and turning them into super practical tools so we can decode the hidden patterns all around us.
Okay, here's our game plan for today. 1. We'll meet the function machine. 2. Tackle input and output tables. 3. Get into writing algebraic rules. 4. See some real-world math in action. And 5. Subscribe for more math. Let's just dive right in.
Section 1. Meet the function machine.
So I want you to imagine a secret black box. You drop a number in, the machine whirs away, and a completely different number pops out. For example, if I give you a 2 and you give me back a 5, what's the hidden rule? What exactly did that box do to our 2? Did it add 3? Maybe it multiplied by 2 and then added 1. Your job as a mathematical detective is to figure out exactly what's going on inside that machine. Now, the textbook officially calls this secret code a function, which is really just a fancy way of saying it's a relationship between two sets of numbers. That's literally the whole shebang. No magic involved, just a consistent, reliable rule connecting a starting number to an ending number. Once you lock down that relationship, you've got the key to the whole sequence. And this breaks it down perfectly. You have your input going in and your output coming right out. It's pure cause and effect. The input is our starting point, our raw material, right? The function machine processes it, and boom, the output is your finished product. Now, in algebra, we really like to keep things organized, which leads us perfectly into our next tool. Section 2. Input and output tables. Okay, check out how organizing the numbers completely exposes the pattern. Look at the inputs on the left, we'll call those x, and the outputs on the right, which are y. When x is 4, y is 1. When x is 5, y is 2. When x is 6, y is 3. I mean, the relationship is just staring right at us. Every single output is exactly 3 less than its starting input. We totally cracked the code for this one.
Moving on to Section 3, Writing Algebraic Rules.
Once you're confident spotting the pattern, translating it into actual algebra is the breeze. It's really just 3 easy steps. First, always anchor yourself by looking at the inputs. Second, figure out the math operation. Are we adding, subtracting, multiplying, or dividing to get that output? And third, just write it out as a formal rule using our letters x and y. Applying those exact steps to the table we just looked at, the hidden rule becomes the algebraic equation y equals x minus 3. To get the output, y, you just take the input, x, and subtract 3. It's elegant, it's quick, and it works flawlessly for every single number pair in that sequence. Guess what? You've officially written an algebraic function.
Let's hit Section 4, Real-World Math in Action.
Now, you might be thinking, okay, but when am I actually going to use this? Well, let's look at a relatable scenario from the Cambridge workbook. Imagine you're manufacturing dinner plates. You've got small plates and matching large plates. If the small plate is 15 centimeters, the large is 22.5. If the small is 16, the large is 24. If we divide the output by the input, like 22.5 divided by 15, we get 1.5. So you can instantly see the large plate is always exactly 1.5 times the size of the small one. And that gives us a super practical algebraic rule, y equals 1.5x. So whether a customer wants a tiny 10-centimeter plate or a massive 100-centimeter one, the manufacturer knows exactly how big to make the matching large plate just by plugging it in to this function. A real game changer. Or, hey, think about planning a huge group trip to a theme park. You know the base ticket cost per person, but, and there's always a but, the park tacks on a flat $12 booking fee for the whole group order, no matter how many tickets you actually buy. How do we turn that real-life annoyance into a simple equation? Well, you can calculate the total cost, t, by using the simple formula t equals b plus 12, where b is just the baseline price of all your tickets. By locking down that function rule, budgeting suddenly becomes absolutely effortless. Just plug in your base cost, add 12, and boom, you have your total. Finally, Section 5, subscribe for more math. Let's do a quick recap of the fundamental building blocks we've mastered in this explainer. 1. A function is simply a relationship between sets of numbers. 2. Input and output tables are your absolute best friend for deducing hidden rules. And 3. Algebra just uses letters to represent these real-world patterns. They aren't just scary letters on a page, they're incredibly useful tools for decoding the world around us.
So if this explainer helped you confidently master Section 11.1 and made functions finally click, do me a huge favor, hit that like button, share it with any classmates who might be struggling, and absolutely make sure to subscribe for more math mastery.
Before we go, think about how those plates and theme park tickets follow completely predictable algebraic rules. I'd love to hear from you. What hidden mathematical functions are operating in the background of your daily routine right now? Leave a comment below with your thoughts, keep practicing those functions, and I'll catch you in the next explainer.